Today's video is going to be about parallelograms, properties of parallelograms, and using those properties to find different values. So the symbol for a parallelogram is this little quadrilateral that looks like a parallelogram, and then we say it's parallelogram ABCD. And I drew a diagram over here. The vertices go in order, A, B, C, D, wherever I choose to start. The definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So I notate that with the arrows. And what that means in this case is that segment AB is parallel to segment CD, and segment AD is parallel to segment BC. We also know that both pairs of opposite sides are congruent. That's a property of parallelograms. So I can mark that, which is just going to tell me that AB is congruent to BC and BC is congruent to AD. I'm going to use that idea when I set up equations. Opposite angles are congruent. Angle A is congruent to angle B, or angle C. Angle B is congruent to angle D. Because we have parallel lines, I know consecutive angles are supplementary, which just means they add up to 180. So measure of angle A plus measure of angle D equals 180. Consecutive, measure of angle D plus measure of angle C equals 180. And then finally, the diagonals bisect each other. We're going to do a separate example of that, but just recall that bisect means cut in half. So if I want to just look at some basic examples, if I say that the measure of angle A is 102 degrees, I can use the fact that opposite angles are congruent and consecutive angles are supplementary to find the measure of all the other angles. So I know angle A and angle B are supplementary, so the measure of angle B equals 78. Opposite angles are congruent. The measure of angle C equals 102 degrees. And the measure of angle D equals 78 degrees. And if I added those up, they would add up to 360 because the total sum of the angles in any quadrilateral is 360 degrees. I could make it a little harder. I could say the measure of angle A equals 3x and the measure of angle C equals 105 and the measure of angle D equals 2y plus 9. So I'm going to look at my diagram. If I say the measure of angle A is 3x, the measure of angle C is 105, and the measure of angle D is 2y plus 9. So to begin with, I'm going to solve for x because opposite angles are congruent. So I'm going to set 3x equal to 105, and when I solve that, I get x equals 35. To find out what the measure of angle D is, I need to know that angle D and angle C are supplementary, or angle D and angle A are supplementary. Well, I know that angle C is 105, so that angle D plus angle C equals 180. So 2y plus 9 plus 105 equals 180. If I just solve this, subtract I end up with 2y equals 66 and y equals 33. I could do a similar thing with sides. If I knew AB and DC, I would simply set those two sides equal to find the value of whatever variable I was looking for. The important thing is to know the difference between whether you're looking at sides or you're looking at angles. Let's look at a little more complicated example. Here I have parallelogram CSUB. Now I put my diagonals in. I know the diagonals bisect each other, and I still have all of my other properties. Opposite sides parallel, opposite sides congruent, angles, and so on. I'm going to do a little bit more with this. So I have the measure of angle 1 is y plus 10. The measure of angle 2 is 3y. The measure of angle 3 is y plus 15. I actually have some extra information that I don't need here. So I'm going to look at my diagram and see what I know. I don't have angle 4, so I can't set the whole angle SCB congruent to angle BUS. I don't know any actual measures of angles, but I do know my properties of parallel lines. So CS is congruent to BU. So if I look at these two parallel lines cut by a transversal, angle 2 and angle 3 are alternate interior angles. And I know that alternate interior angles are congruent. So I'm going to set 3y equal to y plus 15. Angle 2 congruent to angle 3. You might be wondering, what about angle 1? We actually don't need it. There's extra information. If I solve this, I end up with 2y equals 15, and y is 7.5. So these were the only two angles that I needed. If we were asked for more, I could go back and substitute in and find out what my measure of different angles were, but for now we're just going to solve. I'm going to look at one more example that's a little bit more complicated just because of the algebra. And I'm going to erase some of this information here. This example has to do with the fact that the diagonals bisect each other. So I know CM is 2x plus y, MU is 12, BM is x plus 2y, and MS is 9. So I need to set up a system of equations to solve this. Because the diagonals bisect each other, I know that 2x plus y is equal to 12, and I have it labeled there on my diagram. I also know that x plus 2y is equal to 9. This diagram is definitely not drawn to scale. Once I have my two equations, I need to figure out a way to solve. Since I have a y by itself here, I'm just going to subtract 2x and say y is equal to 12 minus 2x. And then I can use that to substitute in to my second equation. You can do this any way you like solving systems of equations. So I have x plus 2 times 12 minus 2x is equal to 9. I just substituted into my second equation. Now I'm going to distribute, and I get x plus 24 minus 4x equals 9. If I combine my like terms here, I end up with negative 3x plus 24. I'm going to subtract 24, and I end up with negative 3x equals negative 15, and then x is equal to 5. Once I get my x is equal to 5, I can go back and substitute into either equation or even this equation to figure out what y is. And since I already have y by itself, I'm going to substitute in here. So y is equal to 12 minus 2 times 5. 2 times 5 is 10. 12 minus 10 is 2. So I end up with y is equal to 2. So what we're going to actually be doing is applying these properties and setting up algebraic equations to figure out x's and y's, or whatever variables we have.